humans love to explore. But now that we have explored a great majority of the Earth, what do? Leave the Earth, of course. Interstellar space travel is the next big leap in the sophistication of our society, but it is also a difficult one. The closest star of the solar system is Proxima Centauri, and Voyager 1 would take over 73,000 years to reach it. Chemical propulsion is a no-go for deep space travel since it can only accelerate for a few minutes and the fuel it carries is many hundreds of times greater than its payload. If you have any hope of becoming an interstellar civilization, you will need to create a fast and efficient propulsion system. There are many types and models of propulsion, so I divided them into 4 main categories to provide an overview of how they work and evaluate their speed and feasibility. The first type is ion propulsion. The engine bombards neutral gases such as xenon in the chamber with electrons knocking off its electrons and creating a plasma of them and positively charged ions. The positive ions are siphoned out and accelerated using high voltage to about 98 kilometers per second. Once it's slow, the acceleration increases speed over time. Ion propulsion is very feasible since the technology has already been developed and it is being used by NASA in the Deep Space One mission and the Dawn spacecraft launched in 2007. The next step of power is, of course, exploding nuclear bombs. Insane, right? Well, not quite. Nuclear fission is being experimented with by NASA. Fusion reactors confine and heat the fuel in a magnetic field using a device called a tokamak. It transfers heat from a reactor into a liquid propellant, converting it into a gas which is accelerated to high exhaust velocities through a nozzle to provide thrust. It is still a work in progress, but is on the way to becoming the primary propellant for a journey to Mars in under 3 months. The next category is the busted ramjet. It is a fusion rocket, but rather than carrying a supply of nuclear fuel, it ionizes hydrogen from the surrounding space, then sucks it in using a huge electromagnetic field scoop. It can sustain a fusion reaction and work its way up to close to the speed of light, which makes it an attractive option for interstellar space travel. It can also utilize exotic matter like dark matter, dark energy, or antimatter. The last major category of propulsion involves using celestial bodies. The Dyson slingshot has a ship get close to a binary neutron star system in such a way that it launches the ship in almost a third of the speed of light. This works like a gravitational assist, but it is much faster since the mass of a neutron star is exponentially greater than a planet. If that isn't insane enough for you, a black hole starship makes an artificial micro black hole and propels itself using Hawking radiation. A reflector would be placed at a fine-tuned distance from the micro black hole so that its emissions are being channeled in one direction and acceleration is imparted. Finally, the Halo Drive by David Kipping beams a laser towards a precisely targeted member of a black hole binary. The light is returned in a blue-shifted form to the spacecraft, and the extra energy is being used to push the craft. Space is an enormous place, but the future is even bigger. We as a species are just beginning to take our first baby steps into the cosmos, the first endeavor into the final frontier. Our generation may be the first to make it into a reality.